Okay, welcome to Calculus and Pre-Cal 2. We're going to start with at the section in the book called P.4, and it is graphs of equations. So we're going to start by sketching the graph of an equation. So what is a graph? A graph is the set of all of the points, the coordinate points x comma y, in which those two coordinates, x and y, those two numbers, when you plug them into an equation, that's the solution. It's a solution. So for example, I have the equation y equals x squared minus 7, and I want to know if the point 3, 2 is on the graph of this equation. So it will be on the graph of the equation if when I plug the point in, I get a true statement, which would be a solution. So the 3 is in the x position, and the 2 is in the y position. So I'm just going to replace the y with 2 and the x with 3, and I get 2 equals 9 minus 7. This is a true statement. 2 does equal 9 minus 7. So yes, the answer to this question is yes, the point 3, 2 is on the graph of y equals x squared minus 7. So that's how you can tell if one point is on a graph. But how do you make the graph from scratch? Well, you can always plot points. So you find a couple of points that are on the graph that make solutions, and then you connect the points, and that's the general shape of the graph. So here we have an example. We want to sketch the graph of y equals 3x to the 4th minus 2x squared. In order to do this, I'm going to make a general chart, x, y, and I'm going to choose values for x, plug them in, and figure out what y would be to make solutions. I will start with negative 2. Then I'm going to do negative 1, 0, 1, and 2. All right, so when I replace the x with negative 2, I get 3 times negative 2 to the 4th minus 2 times negative 2 squared. Please be sure to always plug in numbers in parentheses so that the operations occur to both the number and its sign. Because if you have negative 2 like this, we have to make sure that when we take negative 2 to the 4th power, we do that to the negative as well. So this is 3 times 16 minus 2 times 4, because negative 2 squared is 4. Okay, so 3 times 16 is 48, minus 8, that's 40. So if the y coordinate were 40, then the coordinate negative 2, 40 is a solution, and that would be a point on the graph. Moving on, let's do negative 1. I'm going to go ahead and do this one in my head. I know that negative 1 to the 4th is 1, and negative 1 squared is also 1. So then that would be 3 minus 2, which is 1. 0, I can also plug in my head. That's simply 0. 1, if I plug 1 in, I also get 1. And if I plug 2 in, I'm going to get 40 again. And you can check that out if you'd like. And so now I can sketch a really quick graph. I only have 5 points that I'm going to plot. Those are the only 5 points I determined. Okay, so negative 2, 40, 1, negative 1, 1, 0, 0, 1, 1, and 2, 40. And so this looks like a parabola. It's not a parabola, it's fatter at the bottom, but it looks like a parabola. And there is a sketch of the graph. Okay, intercepts. Next topic. We're going to talk about intercepts. There are 2 types of intercepts, x-intercepts, x-intercepts, and y-intercepts. Okay, so x-intercepts are where the graph crosses the x-axis, not the y-axis, the x-axis. That's why they're called x-intercepts. And similarly, the y-intercepts are where we cross the y-axis. On the x-axis, every y coordinate point is 0. Right? If you're on the x-axis down here, then every point on that has a y coordinate of 0. You don't go up or down any. Conversely, for the y-intercept, or for the y-intercepts and the y-axis, all of the x coordinates are 0. So that's where you switch the letter a little bit. So if I want to find the x-intercepts of the equation y equals 3x to the fourth minus 2x squared, I will set y equal to 0. So to find x-intercepts, you set y equal to 0, and then you solve for x. Okay, the way to solve is similar. It's going to be the same every time almost. You want a 0 on one side, and then you want to factor. Okay, so now that I've factored, I can set each factor equal to 0. This only works if you have a 0 over here, though. Okay, so x equals 0 is one of my solutions. And then now, if I solve for x squared, I get 2/3. If I take the square root of 2/3, I get the square root of 2 over the square root of 3. And so there are actually two solutions here. One when you have positive square root of 2/3 and one when you have negative square root of 2/3, because there are two numbers that when you square them, you get positive 2/3. Those two numbers are positive square root of 2/3 and negative square root of 2/3. So now for the y-intercepts, I'm going to make x 0. So I just replace the x with a 0, and I get y equals 0. So there were two x-intercepts, 0, 0, or three x-intercepts, radical 2/3, 0, and negative radical 2/3, 0, and then there's one y-intercept, 0, 0. It's the same as this x-intercept, right? Because it crosses both, it's the origin. Symmetry, next topic, and then we have one more topic after this. Symmetry, three types of graphical symmetry: x-axis symmetry, y-axis symmetry, and origin symmetry. Things that are symmetric across the x-axis reflect over the x-axis. So I'm going to draw some butterflies here. So if I have half of a butterfly up here, then x-axis symmetry means the other half of the butterfly is down there. In y-axis symmetry, whatever you have on one side of the y-axis, say I have this here and this there, then you also have that on the other side of the y-axis. So this reflects over to that, and then that. Okay, this didn't quite look the same. There we go. And finally, origin symmetry. Origin symmetry is weird. It's both x-axis and y-axis symmetry. In origin symmetry, whatever happens here happens here. So it's not actually both. If you have both x-axis symmetry and y-axis symmetry, you also have origin symmetry. But what really happens is if you can turn your paper 180 degrees upside down, your picture stays the same. All right, you're going to have to figure this out algebraically, though. So for x-axis symmetry, if you replace y with negative y, the equation stays the same. This is what it means to have x-axis symmetry. So you replace y with negative y and simplify. So, for example, all your negatives, when you squared those would go away. For y-axis symmetry, it's the same idea. But on this one, we're going to replace x with negative x and simplify. And there, the equation remains the same. If the equation does not remain the same, then you do not have that type of symmetry. The equation remains the same. Okay, finally, for origin symmetry, we replace both x and y. So we replace both x and y with negative x and negative y. Simplify. And then if the same equation that you started with, then it has origin symmetry. All right, so let's do this. So we're going to test our example that we've been using this whole time. So let's test for x-axis symmetry. For x-axis symmetry, I replace y with negative y. Okay, so when I replace y with negative y, I have negative y equals 3x to the fourth minus 2x squared. If I multiply through by a negative 1 to get the y by itself, then I'll have y equals negative 3x to the fourth plus 2x squared. This is not the same equation, and so we do not have x-axis symmetry. Now let's try for y-axis symmetry. For y-axis symmetry, I replace x with negative x. So now I have 3 times negative x to the fourth minus 2 times negative x squared. When you follow order of operations, you do the exponents first here. So a negative x to the fourth power, well, a negative times itself 4 times is positive. This is just 3x to the fourth. Same thing happens with the squared, minus 2x squared. And so now you can see how an equation can remain the same. This looks exactly the same as the question. And so, yes, we have y-axis symmetry. And if you go back to the sketch I did, can you see that we have y-axis symmetry? First page. Yes, so here's the y-axis. Everything on the right is also on the left. Okay, going back to the page I was on. We're going to go ahead and test for origin symmetry, but it will not have it. And the reason why I know is because it didn't also have x-axis symmetry. So the options are either x-axis only, y-axis only, all three choices. This is all three choices. Origin only, or none. Okay, but you can't have two. You either have essentially all or none. So, but I will show you that it doesn't have origin symmetry. It's just the same as the x-axis symmetry. You end up with the same thing because the negatives go away on the x's but not on the y. So, no. All right. Last page. This is reviewing circles. Okay, so with circles, there is a standard form, and you need to have this memorized. The standard form for the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. And in this formula, it's a form, standard form is what it's called, but form stands for formula here. In this formula, the h and the k, okay, these are numbers. They're numbers. I know that they look like letters, but they're in place of the numbers, whatever numbers those are. That is the center of the circle. So the center is h comma k. And then the r is also a number, and it is, surprise, surprise, the radius. The radius is r. And so for a standard equation of a circle, you need the center and the radius. The center is what you subtract from the x, and the y inside of parentheses squared equals r squared. There has to be a plus here as well. Okay, so for example, we have a circle whose center is 2, negative 3, just to give you a picture of it. And the point 1, 1 is going to be on it. All right, so 1, 1 is here. And so this is going to be my circle. How do I find the equation of this circle? Well, I'm going to use standard form. I have to know the center. Okay, check. I know the center. It's 2, negative 3. So that's hk. So when I plug into my formula, x minus h squared plus y minus k squared equals r squared. Then I replace the x with 2. So now I subtract 2. And I replace the k with negative 3. So I subtract negative 3. When you subtract a negative, that's adding. All right, so the only thing left to determine is the radius. And how do I figure out what the radius is? Well, I know another point on the circle. There are a couple of ways you can do this. One is you can just use the distance formula and find out whatever the distance between 1, 1 and 2, negative 3 is. I'm going to do a different way. I know that 1, 1 is on the circle, right? It's on the graph. If a point is on the graph, then that means that it's a solution to the equation. So that means if I plug in, I should get a true statement. So I'm going to go ahead and just plug in. I'll replace x with 1 and y with 1. So I have 1 minus 2 squared plus 1 plus 3 squared equals r squared. This means that negative 1 squared plus 4 squared equals r squared, or 1 plus 16 is r squared. So r squared is 17, which is great because I just need to know what, well, r, then to square it is. So r squared is 17. That means my equation is x minus 2 squared plus y plus 3 squared equals 17. There is a solution. And I believe that this is the end. So see you tomorrow.